So in 12.2 yesterday, we talked about permutation. And if you go back and look, or if you recall, permutations are when order does matter. Okay, when we're arranging things, order does matter. Today we're going to start by looking at the other part of this, which is combinations. And combinations is a set of objects with no specific order. So you will often hear me say order does not matter. Okay? Now you will notice we have a formula again. The number of combinations of R objects taken from a set of N objects. Our formula is very similar, isn't it? Okay, NCR, so N items, combination of picking from N items, picking R at a time, and it's still N factorial on top. On bottom, though, there's an R factorial in front of the N minus R factorial. So similar, you have to add a little piece. Now, we're going to practice using this formula, and then I will eventually show calculator buttons when we get to doing some probability. But again, as I said, I'm not against you guys using the calculators, but you also have to know how to set up these permutations and combinations. So, okay, Marisol is planning to be a counselor at summer camp. She can choose 3 activities for her session. And then our question is, how many different combinations of 3 activities are possible? Now, it uses the word combinations. That's like the big clue. We're on the combination page. That's the big clue. But think about what's going on here. It's combinations of 3 activities. She's picking 3 activities. Does it say anything about order, about arranging these? No, it's just asking how many different combinations are possible. So if that's the case, we're going to do the combination. How many things are we picking from?
10.
10 because if you count the listing here on the screen? Yeah. Okay, there's 10 different things listed on the screen. So it's a combination of picking from 10 items. And how many are we picking?
3.
3, because she's picking 3 activities. Now, formula-wise, on top, N factorial, which is 10. And keep in mind, just like yesterday, yes, the first number is always bigger than, larger than, or equal to the second number, never smaller. Divided by, on bottom now, this is the new part, R factorial, which is the second number, 3 factorial. And then divided, and then also N minus R, so
10
minus 3. Mm-hmm. I'm going to clean it up, and then we're going to work it out. So 10 factorial over 3 factorial times 7 factorial. One thing I will point out here. Notice 7 plus 3 equals 10, yes? That's not a coincidence. Your 2 bottom numbers in a combination will always add up to be that top number. Okay? Now, like yesterday, we're going to work this out. I'm going to show you some tricks again. Okay? I will say with a combination, you have to do the formula. With a permutation, you have to say with the formula or just setting up blanks. We don't have that with a combination as easily. So, remind me, what does 10 factorial mean?
10 times 9 times 8 times 5 times. Yep.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All multiplied together. Okay? What is the denominator? 3 factorial means 3 times 2 times 1. 7 factorial means? Okay, 7, 6, 5, 4, 3, 2, 1. Now, tricks from yesterday. Do you remember them?
Yes.
Okay. We can cancel right off the bat.
7, 6, 5, 4, 3, 2, 1.
7 through 1, top and bottom.
Yep.
Now, you can stop at this point and you can put the numbers into your calculator. However, I also want to show you a little bit more canceling that can be done. On bottom, I still have a 3 times a 2 and then times a 1. I don't really care about the 1 because it's not going to matter, but 3. While there's no 3 on top,
9.
what is there on top?
9.
There's 9, and 9 is divisible by 3. So we can do like a canceling thing. 3 divided by 3 is going to be 1. 9 divided by 3 becomes a 3. We can do the same thing with the 2.
2, 8, or 10. 2 with the 8 working 10.
Okay. You do you. Did you see 2 goes into 10 first, or did you see 2 goes into 8 first? Okay. If we see 10, then go with 10. 2 divided by 2 is 1. 10 divided by 2 is 5. You only get to cancel with the 2 once, though. So you don't get to use the 10 and the 8. Now, on bottom, all that I have left are 1s. So we've canceled as much as we can. And you're ready to multiply. What do we have left to multiply?
5 times 3 times
5 times 3 times 8.
120.
5 times 3 times 8 is 120. Okay? The more numbers you get canceled, the less numbers you have left. The more likely, there's just fewer numbers to plug in. There's also more that you can just do in your head. Okay, questions with that?
No.
Okay, let's practice again then. How many ways can a camper choose 5 activities from the 10 available activities at the summer camp? Choosing 5. So that means we're going to do what? Okay, combination of 10 items, chosen 5 at a time. Okay, practice this setup with me a little bit. On top, we're doing 10 factorial. On bottom, it's r factorial first, which is 5 factorial. And then the second piece is n minus r, so 10 minus 5 factorial. Clean it up. 10 factorial on top. On bottom is 5 factorial times 5 factorial. Notice 5 plus 5 is 10, isn't it?
Yes.
Okay. On top, 10 factorial means
10, 9, 8, 7, 6, 5, 4, 3, 2.
okay. What she said, yes? 10 all the way down to 1. 5 factorial means
5, 4, 3, 2.
5, 4, 3, 2, 1. Another 5 factorial means
5, 4, 3, 2.
another 5, 4, 3, 2, 1. Practice the canceling as we go. The obvious thing I would always start with, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. Notice I don't even cancel them individually. I just, one fell swoop, get them out of there. Now, thoughts of what you want to cancel next.
10 and 5.
Okay, now, if we do 10 and 5, what's going to be left from the 10?
2.
2. What else do we have down here?
2.
A 2. So what do you know about 2 times 5?
That's 10.
It's 10. And what do we have on top?
10.
A 10. So could I cancel the 2 and the 5 with the 10?
You can do it a different. I did it a totally
I
different
did
way.
it differently. I saved the 2.
I saved the 2 for the 6.
Okay, and here's the deal. We're all going to get the same answer in the end. Okay? So I personally was going to say 5 times 2 cancels with 10. Sounds like several of you did. 5 divides into 10 and you have a 2 left there, yes? That's fine. Keep going. Meet me in the end. I think you'll be okay. Now,
40.
4 can go with 8. 4 divided by 4 is 1. 8 divided by 4 becomes 2. 3 could go with
9.
9 or
6.
6. It doesn't matter. Okay, you just get to pick one though. So 3 divided by 3 is 1. You guys want me to go 9?
Yeah.
9 divided by 3 is 3. Okay, so for me, when I grab my calculator and go to punch this in, I'm punching in 3 times 2 times 7 times
I
6.
got the same answer.
Okay, when I punch in 3 times 2 times 7 times 6, what am I getting?
You're going to get 252.
252? Okay, now,
What do you
if
think?
some of you tried a little bit of different canceling, did it work out in the end?
Yeah.
Okay, if you do the canceling legitimately, don't make careless mistakes, basically. We'll meet in the end. Okay, questions here? Yes.
With the C, how do you tell when the 10 and 5 go there together?
Like this 10 and 5?
Yeah.
Because in this case, we are picking from the 10 available activities. So it's how many things are you picking from? And then how many are we trying to pick? We're trying to, like what I say is fill 5 slots. We're trying to pick 5 things. So we're picking from 10 things, and we're trying to pick 5 of them. Does that make sense?
Yeah.
Okay. And as I said, the bigger number is always first, or the numbers are the same. Okay, but you'll never have a smaller number first. Okay, let's practice a little bit more with these combinations. What is 9C2? So combination of 9 things chosen 2 at a time. How do we set up 9C2?
9.
On top, it's in, so 9 factorial.
Over 7 factorial. Oh, that's excellent. 2 factorial. 7 factorial.
I agree. I'm just not writing it that way yet. Okay, I'm sticking with the formula. 9 factorial on top, that's n. R is 2, 2 factorial. And then n minus r, 9 minus 2. So it does clean up to be 9 factorial over 2 factorial times 7 factorial. Okay. Do the math with me again. 9 is 9 factorial, 9, 8, 7, 6, 5, 4, 3, 2, 1. 2 factorial is
2, 1.
2 times 1, 7 factorial. 7, 6, 5, 4, 3, 2, 1. What cancels?
Everything but the 1.
Okay. 7 through 1 cancels, yes. That's the easy way to get out of there. And then, what else can you do? 2 divided by 2 is 1. 8 divided by 2 becomes 4. All we have left on bottom is just 1s. What's on top? 9 times 4, which is 36. Now, let's look at B. Okay. 9C7. So the combination now, it's 9 things, but chosen 7 at a time. Okay. Follow along. On top, n factorial is going to be 9 factorial. On bottom, r factorial is 7 factorial. N minus r is 9 minus 7 factorial. Clean it up. 9 factorial over 7 factorial, 2 factorial.
It's the same thing.
Okay, we can work this all out. Or, what are you noticing?
It's 36.
Because?
It's the same.
It's the same thing.
Okay. Up there it was 9 and then 2 and then 7. 9 factorial, 2 factorial, 7 factorial. Here it's still 9 on top and the 7 and 2 just flip spots. Does that matter? No. It's going to be the same thing. Now, don't believe me. Work it out. But I'm going to shortcut and say this is
Definitely 36.
36. Okay. Now, C is where we tie this together. What is the relationship between the answers to A and B?
They're the same.
They're the same. State the obvious for me, thank you. Now, why?
Because they're
Because
the same
it's a
thing.
combination.
With the end, because they have this, they're the same with an answer of 36.
Okay,
They both add up to 9 on top.
okay. Those bottom numbers are the same, just flip-flopped, right? So the denominators, because the 2 and 7, basically, because they add up to 9, they're going to end up being the same answer because those numbers in the denominator are going to end up being the same. Okay, so relationship. A and B have the same answers. And it has to do with we're picking how many slots. Those slots add up to be 9, right? But ultimately it ends up their denominators are the same. So I'm just going to say just that. Their denominators end up the same. Okay. Get what you need from there. And that's your introduction to combinations. Yesterday we did a lot of permutations. Today a few combinations. Now we've got to start putting it all together. So,
Hear me out.
nope,
Hear me out. You just tell us which is which.
nope.
Ace the 10.
Hey, this goes with the statistics, right? There's 2 of them. So what's set up here?
Statistically, what is combination?
Okay, so okay, listen and think. This question is just asking, do the possible outcomes represent permutations or combinations? We're not even, on this particular example, we're not being asked to find it. It's just, I want to know, does this represent permutation? And a permutation would mean order does matter. Or does it represent a combination where order does not matter? That's what you're asking yourself here. Now, on A, Jennifer will invite 3 of her friends to a concert.
Combination.
Does order matter of her 3 friends she invites? You just want to be one of those 3 friends, right? Does it matter if you're picked first, second, or third?
What if it's a stupid concert?
You know what I mean. Okay? So, this is a combination. It is a combination. And I'm going to put a reason over here just so we can get it in our head, and that is because order
Does not matter.
does not matter. Now, you're required to let me read B all the way. And you're required to pause and think. Okay? Now, she picked her 3 friends. Now Jennifer must decide how she and her 3 friends will sit at the concert.
Order.
I think it might be permutation.
Okay? Now, not because of the statistics, but why does order matter here?
It depends on who she wants to sit by.
Yeah, so if, who has the first seat, the second seat, the third seat, the fourth seat, there's more than one option there, aren't there? Okay, and so this is, at this point, she's arranging the people in the seats. When you're arranging the people in the seats, order matters. So, thus, as you already know, this is a permutation. So order does matter. Okay? This is one of the harder parts of the lesson. Giving you the find this permutation, find this combination, you guys can plug the numbers in and go. The part is distinguishing what to use when. Okay? Now, in this next section, we're actually going to find them. Okay? I didn't put directions here for whatever reason, who knows. But we're actually going to answer these questions. Question 1. How many different ways can a 4-person team be chosen from a group of 8 people?
Combination.
So the first question you have to ask yourself before we set this up is, does order matter? Are we going to set up a permutation or combination? How many different ways can a 4-person team be chosen from a group of 8?
Combination.
Is there anything indicating that order matters?
No.
No, it's picking a 4-person team. Kind of like when Jennifer was picking her friends. It doesn't matter where you get picked on that team. It's just, did you get picked? So, this is going to be a combination. Now, combination, how many things are you picking from?
From 8.
You're picking from 8 people. And how many spots, how many are we trying to pick? How many spots are we trying to fill? 4. So this is 8C4. Agreed? Okay. Let's practice. 8C4. What goes on top? in factorial, 8 factorial. On bottom,
4 factorial.
4 factorial, and then
8 minus
8 minus 4 factorial. This combination has them both on bottom. So if you clean it up, it's 8 factorial over 4 factorial times 4 factorial. Sorry, I didn't leave quite enough room there. Write small. Sorry for those that don't. Okay, 8 factorial means
8 times 7 times 6 times 5 times 4 times 3 times 6.
8, 7, 6, 5, 4, 3, 2, 1. 4 factorial. 4, 3, 2, 1 times another 4 factorial. 4, 3, 2, 1.
Cancels.
Okay, you see the canceling, right? I would start with 4, 3, 2, 1, 4, 3, 2, 1. What else do you see?
4 and
4 and 2. Take the 8 away.
Okay, could we do that option?
good.
Okay, one option. 4 times 2 will cancel with 8. Now, if someone else said, oh, but I did 3 times 2 cancel with 6. That's okay, right? You just won't fully cancel the 8. Now, all I have left is a 3. What's the 3 cancel with? 6. 3 divided by 3 is 1. 6 divided by 3 leaves me with 2.
7 times 2 times 5 over 1.
I could do that in my head. 7 times 2 times 5? 2 times 5 is 10. Times 7 is 70. Or, yep, 7 times 5 is 35. Times 2 is 70. One way or another, you're getting 70. And again, if you're not all into this canceling, could you technically type it all in the calculator?
Yes.
Yeah, I just feel like I'm more likely to make an error punching a button, but that's me. Okay, you ready for 2?
I think it's permutation.
How many ways can 12 runners in a race finish first, second, and third?
Permutation.
Does order matter?
Places.
We're talking places.
But it does matter if you get first, second, or third.
Okay, yeah. Anytime you start talking places, that's assigning positions. You want first, right? You don't want second or third. You want first. There's a difference. Okay, so this is going to be a permutation. Okay, permutation. How many are we picking from? 12. How many spots are you trying to fill?
3.
3, because it's first, second, third. Are you with me? Now, how do you want to do this one?
Throw it in the calculator.
Not quite there yet.
Yeah.
Do a list.
Okay,
Sweet.
here's the deal.
Lists are
I'm not doing a list. Oof, no.
No, she means like the
No, the like
the first, second,
places.
third.
Okay, so that's what, we have an option to use the formula, yes? The other option, with a permutation, how many spots are we trying to fill? 3, yes?
Fill the
How many people could have finished first?
12.
12. Someone finishes first. How many people could finish second?
11.
11, because someone already finished first. Someone finished first, someone finished second. How many people could finish third? 10. Now, here's the deal. You do the formula with me, guess what numbers you also end up multiplying?
Those 3.
Those 3 right there. So, the formula, let's review the formula with me real quick. Permutation formula. On top was still 12 factorial, n factorial. What was on bottom of permutation?
Minus 5.
It's just the n minus r portion. So it's just the 12 minus 3, right? There's no extra r piece there. So now we have 12 factorial over 9 factorial. Well, 12 factorial is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Or maybe you cut that off and quit writing because you did. That's fine. Denominator, 9 factorial 9, 8, 7, 6, 5, 4, 3, 2, 1. What happens? 9 to 1 cancels. What are we left with? 12 times 11 times 10. So there's proof it works for you, okay? What is 12 times 11 times 10?
1320.
1,320.
My calculator says.
Okay. Okay, one more. Then we're going to talk about some probability. Now, you have to think on this one. In how many ways can 11 contestants for an award be narrowed down to 3 finalists?
It does not.
It does not matter.
You guys agree? And I say you have to think because the statistics aren't happening here, right? We already had one of each. This is problem number 3.
Statistically, it's gonna be the first one.
Special occasion.
Okay. So, you're narrowing down to 3 finalists. Does it matter which finalist you are?
As long as you're not the one that got stuck being before.
So, combination, order does not matter. How many are we picking from?
11.
11. How many spots are we trying to fill?
3.
3. You guys are getting that part, it sounds like. And I think you know how to set this up. On top,
11.
11 factorial. On bottom,
3.
now this is a combination, so you have to do
3 factorial.
r factorial, which is a 3 factorial. And then you also have to do
11 minus 3.
n minus r. So 11 minus 3 factorial. So 11 factorial over 3 factorial times 8 factorial. 11 factorial, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial, 3, 2, 1. 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1. I'll be honest, if I was writing this out on my own, there's some numbers I would skip here. Okay? I just hesitate to do that in front of a whole class. Okay, did you get some canceling happening? 8 through 1 is gone. And what else did you cancel?
3 and 9 and 2 and 10.
Okay, 3 cancels with 9. 3 divided by 3 is gone. 9 divided by 3 is 3. 10 cancels with 2. 2 divided by 2 is 1 or gone. 10 divided by 2 is 5. So I have 11 times 5 times 3,
160.
which is 165. Okay, and again, you could end up just typing in 11 times 10 times 9 and dividing by 6 just as well. Okay? Okay, make sure you have everything you need. Then we're going to go talk about some probability. Have a calculator by your side. You'll want it. Okay, we have what we need from this page. Okay, we're going to talk about how we can use permutations and combinations to find probability. Here we have the situation. A teacher chooses 5 students at random from the names shown to work together on a group project. Okay? 2 questions. The first one is, what is the probability that the 5 students' names begin with a consonant? Okay, so think about it. Probability. The bottom of a fraction in probability is all the possible outcomes, right? On top is what we call the favorable outcome. So in this case, it will be how many students' names begin with a consonant, okay, when you have a group of 5. Now, we need some information from this chart. First of all, how many names are we looking at here?
18.
You've counted, there's 18 names, yes? Just gathering information. And then for part A, we need how many students' names begin with a consonant. What is a consonant? Let's pause there. What is a consonant?
Any letter that's not A.
There's 12 of them.
Okay, so as someone first hour said, opposite of a vowel, right? Not vowels. So vowels are A-E-I-O-U, consonants are everything else. How many names begin with consonants here?
13 actually.
13.
I have 13 written down.
Because there has to be 5 purposes.
Okay, now, with that in mind, probability. We're going to think fraction, right? We are looking at all the possible groups on bottom. Now, with that in mind, how many students are you picking from?
13.
18.
For the denominator, 18. We're picking from all 18 students. And we're wanting groups of what?
5.
Groups of 5. So that is the combination of 18 students picked 5 at a time. Which, by the way, I skipped that step, didn't I? Does combination make sense here?
Yeah.
And I'll say, and more often than not, I feel like combination is what we use here. But does it matter what order they pick the 5 students' names in? It does not. So we are going to think combinations on this problem. Now, so in order to get all the groups of 5, you're picking from 18 students, 5 at a time.
So why do you put a liner in the C?
Are you talking about this?
Yes.
I'm getting ready, I'm setting up probability. So we have to figure out what goes on top. So the bottom is all of them. All 18 kids put in groups of 5. What do we need on top then?
13 and 5.
There's only 13 that begin with consonants. So we're picking from those 13 kids and doing combinations of 5. Now, we could write that all out by hand. We could learn the calculator. What you feeling?
Calculator.
Calculator.
Okay, get your calculator in front of you. I, of course, am going to demonstrate on my calculator. However, every calculator has this
At
option.
this time, the majority of 8th graders are back to class. Teachers, there are a few 8th graders still finishing up. 7th grade, you're going to report to your testing rooms. 7th graders, if you are coming into the gym, you must enter the gym quietly and find your seat. Again, 7th graders, you must enter the gym quietly and find your seats. Do not go to the restroom at the gym. If you need to go to the restroom, you stop before you get to the gym. Thank you.
Okay. Now, on my calculator, I'm looking for the probability button. If you are working on a different calculator, look for some kind of probability button, or maybe it's just a piece there. But when I hit PRB right here, probability, it brings up this little menu that has NPR, NCR, and factorial, the exclamation point. Okay? So those are the different things we can use. Now, I have to clear out because in order to do this, I have to enter my first number. So if I want to do 13C5, I'm going to clear my calculator screen. I'm going to type in 13. I'm going to go back to my probability button. What do I want? NCR. So I'm going to arrow over. Now notice my calculator says 13, NCR. What number am I typing afterwards? 5. If your calculator gave you 1287, you figured out how to do a combination on your calculator. Okay? It's on there somewhere. You just have to figure it out. Go in your math menu, Eli.
Yeah.
And then you arrow over about 3 menus to the right. To your probability menu. And there you go. Okay?
Some captions.
Okay. Did you try the other one? I'm going to type in 18. I'm going to use my probability button. NCR 5. Again, check and make sure you're getting the same numbers. If so, you figured it out. If not, keep looking for the buttons. They're there somewhere. Okay? I just don't necessarily know where. And it's knowing how do you use the calculator buttons. Did you find yours? Try the math menu, and arrow over to probability. Should be in there. Same thing, try the math menu.
I got it, but I didn't.
So hit enter. So, okay, you need to go back, clear out, and type your first number first, and then go in the menu and pick it. Does that make sense? Yeah, and then type in whatever your other number is. Okay? It's on all of your calculators somewhere, that's what I will tell you. Casio's, is it pretty obvious to find on yours, I think?
Yeah, it should.
It's just the buttons are right there, aren't they? You found them yesterday.
Yeah.
Okay. Okay, keep going on this, divide it out. Probability, what do we get?
15%.
Yeah. 0.15021 is what I wrote down, so then I have it rounded to 15%. Okay. Part B. What is the probability that the 5 students' names end with a vowel?
There's 12 of them.
Have we counted through to see how many students end with a vowel? How many did you say?
13.
12.
I say I have written down 12 on my paper. Okay, so what's the probability that the student's name ends with a vowel? Well, in the denominator,
Still the
you're still
18.
wanting all the groups, yes? So that is 18 students put in groups of 5. What are we doing on top?
12C5.
Okay, 12C5. Are you trying out your calculator? Okay. It's a nice handy button to have, isn't it? 12C5, what are you getting? 719. Yep, you got it. 18C5. We already knew it was 8568. We're going to divide and get, I have 0.09243. For whatever reason, I have this one to 2 decimal places. Don't ask, I'm not sure why.
I just put 9%.
I agree, it's 9%. I have it written as 9.24% on mine. Not consistent, so don't ask me why I did that, but okay. You guys know, do whatever Savas tells you to do. Okay, calculators are good, right? If not, see me later and ask me. If it's not one of my normal calculators, I can help you find it, okay? A company wants to form a committee of 4 people from its 12 employees. How can you use combinations to find the probability that the 4 people newest to the company will be selected? Okay, it told us right up front, right? Combinations. We're talking probability. So when I go to set this up, what's all the possibilities that we're going to put on bottom?
12 employees.
We're picking from 12 employees. How many spots are we picking from for? 4. So on bottom, 12C4, the combination of 12 items picked 4 at a time. On top, what are we trying to do? We want the 4 people newest to the company selected.
4C4.
Okay, so you're picking from the 4 newest people to fill 4 slots. So 4C4. Now, think about this, guys. Order doesn't matter here. 4 people to fill 4 spots. What's 4C4 work out to be? It's 1, yes? And I will tell you, a combination where the numbers are the same, it's always 1. Over?
495.
495.
Yep.
Now, guess what? This one, I just left as a fraction.
Oh, yeah, that's good.
Just going to keep you on your toes here.
Also, 0.2%.
Not going to argue, it very well could be. Okay, where am I at?
3 minutes.
Okay. We're going to look at the next section briefly. You're going to see some probability in homework, yes? I've done several examples. You're getting the idea at least, because I'm not going to come back and finish these notes tomorrow because I've got to keep us on the move here. But as you look at them, I will tell you, most of the time, I feel like when we do probability, it's going to be using combinations. Okay? Might even be a possibility it could work with either or.
There's one at the bottom that I think is.
This one, yeah. I think you can actually use both here, but this one, the order, it talks about order. So that one you are more likely to be talking about permutation down here. Okay, and that one's those are a little trickier. Up here, students will be chosen at random for school spirit awards. 6 athletes, 8 non-athletes who are eligible for 2 possible prizes. What's each probability? Is order going to matter?
No.
No, you're picking for 2 prizes. It's not first versus second. So you would be setting this up with
The first one, would it be like
combinations. Okay?
15 C2 over 6 C2?
I think you reversed it, but okay. Here, real quick, we won't do the math, but I'm just going to set it up for you. Both prizes are awarded to athletes. What's the total? That's what I need you guys to get with me real quick. There are how many people we're picking from, and that is, we're picking from 14 total people. How many spots are we awarding?
2.
2 prizes. Now, in this case, both prizes are awarded to athletes. How many athletes are you picking?
6.
And you're awarding them to how many people? 2. And then, of course, you would do the math there, right? I will tell you, 1591st is what I have written down. Okay. You've seen most. We had to skip a few. Homework. Get 12-3 done for tomorrow. I would encourage you to spend the time. Don't wait till tomorrow in class, because tomorrow in class, I'm going to hand you out a review worksheet. You want to have time to be working on the review worksheet, not playing catch up on syllabus. Okay? Several of you are a couple of assignments behind, so make sure you get those taught as well.